In a previous video about the introduction to the multiplication, we said that there were many different ways to multiply. We said that multiplying means making equal groups. We also said that we could multiply using area models, using number lines, that we could multiply using bar diagrams, or also called tape diagrams. But today we're gonna focus especially on multiplying using area models. Now, in the previous video, we also said that when we teach a new concept in math, we always go from the concrete to the abstract part of learning. We go from concrete, then we move to representational, and then we go to the abstract. What is the concrete? The concrete is the manipulatives, the things that the kids can touch, that they can manipulate, that they can move around, because learning goes from the hand to the brain. The second thing they do is representational. Once they can do it with their hands in a kinesthetic way, then they do it with pictures, with graphs.
Dr. Huffman, please call the office.
Sorry about that.
Dr. Huffman, please call the office. Thank you.
Now, the next one would be the abstract part of learning, which is the numbers, the algorithms. So let's today use some manipulatives to multiply numbers. That's the first thing that the kids are gonna do and use before multiplying, to see if it goes straight from the hand to the brain, and to see if they connect the concrete with the representational as a way to explain the abstract later on. So, we are going to we're going to use Based-in blocks. Based-in blocks have ones, tens, that one dropped, and hundreds. So we have ones, tens. The tens have 10 ones. 1, 2, 3, 4, 5. It has 10. A 10 has 10 ones. These tens are also called rods. Ones, tens. Now let's go to the hundreds. The hundreds have 10 tens. It has 10 tens on this side, on this dimension, and it has 10 tens on this dimension, on this side. 1, 2, 3, 4, 5, 10 tens equal 100. So, ones, tens, hundreds. Let's use this. Let's multiply 13 times 12. I know that 12 is made of 10 and 2. 1 10, 2 ones. 13 is made of 1 10, 3 ones. Let's do this. Let's do the 12. To multiply 12 times 13, I will go with my 10 and then 2, because 10 and 2 equals 12. And now I have my first factor, 12. The second one will be 13. For 13, I have 10 and 3. I'm trying to make this a little bit straight. I don't know how it's looking. 12, 11, 12, and 13. 10 and 3, 10 and 2. So 10 and 2 equal 12. 10 and 3 equal 13. And then we're going to multiply those numbers. Let's do it. The answer, the product, is going to be inside. But there is a key. We're going to fill up this area without gaps or overlaps. Let's do it. Can I fill this area with ones? Yes, I can fill it up with ones. But can you imagine the work? Filling up a lot of ones here, like tens of ones. So maybe, can I use maybe 10s instead and put those 10s here? Yeah, but do I have a bigger unit that I can use? And that would save me time. I can use the hundreds, right? The hundreds, so let's see. Can I use the hundreds here? Yep, there you go. I have 100. Now, question, can I use another 100 here? No, I can't. You know why? Because if I put the 100 here, I will have this gap. And remember, when I do this area model multiplication using manipulatives, I cannot leave any gaps or overlaps. So, no, I cannot use this 100, but I can use 10s. So I will fill this up with 10, another 10, and another 10. Is it looking now like a perfect rectangle here? Yes, it is, but what about this side? Can I leave it like that? No, it has to be a perfect rectangle. No gaps, no overlaps. So let's do it. I'm gonna use another 10 on this side, and then 10 on this side, and that's gonna be 20, but then, can I use another 10 here for this? No. What can I use here? Right, I can use ones. Ones, so let's do the ones. So I have ones. And then I think I need 3 more ones. I got it. That is a perfect rectangle inside with no gaps or overlaps. So let's see what happened here. I have 12, my first factor, and 13, my second factor. How did I get 100 here? Easy. What number gives me 100? 10 times 10 equals 100. That is my first partial product. I'm going to get those partial products out, and I'm going to add them up. Then how do I get my second partial product? It is 10, 20, 30. That is 10 times 3 equals 30. Now, this is my other partial product. 10, 20. How did I get 20? 2 times 10. Now, my last partial product. What do you think? How did I get it? Right. 2 times 3 equals 6. Let me add these numbers here and find the sum of those partial products. Let's do it. 6. 3 plus 2 equals 5. And then I have a 1 here. 5. 1 times 13 equals 156. This is the way we multiply using manipulatives. Now, how do we move now from the concrete, which is the manipulatives, to the representational? Let's do it. And let's see how those two look very similar, okay? You just keep checking and see what is similar between this and what is coming up, okay? But let me remove this from here. And let's do this again, this time just with the area model. Let's do the same one. 12 times 13. Let me get my area model. It looks like a rectangle, right? But then I have to put my factors on the rectangle, right? One is gonna be on this dimension, and the other one is gonna be on this dimension. How do I get these numbers here? Can I just put 12 here and 13 here, or vice versa? No, I need to do something first. I need to decompose the numbers. Decompose means breaking them apart into place value units. So for that, I'm gonna use a strategy that is called the number bond. So how do I use a number bond? It's easy. 12 is made up of 1 10 and 2 1s. 13, I'm gonna use my number bond again, is made up of 1 10 and 3 1s. Since this dimension is longer, I'm going to put my greater number on the top. 10 and 3. Make this a little bit better looking. All right. And then my second number, because it is less, I'm going to put it on this side. 10 and 2. Now, since that's plus. Since 10 is greater than 3, I'm going to show that here. That 10 portion is greater than the 3. And then down here, I'm going to show that the 2 is less than the 3. So I'm going to make it smaller here somehow. There you go. Now let's multiply. Let's find the partial products. Do you see so far a similarity between this and what we just did with the manipulatives? It's kind of similar, right? Look at this. I'm gonna find the first partial product. I will multiply 10 times 10. 10 times 10 equals 100. I got my first partial product. Do you remember this 100 from the previous one? The same, right? The same one, right? Let's do the second one. 10 times 3. 10 times 3 equals 30. The same partial product we got before. Now let's do this one here. 2 times 10 equals 20. And then the last one is 2 times 3. 2 times 3 equals 6. Now I got my partial products. Now let's add them up. I have 100, that's my first partial product. I have 30, that is my second partial product. I have 20, that is my third partial product. And now I have 6, that is my last partial product. I'm going to add those partial products to find the sum of them. So 6, this is a 5, and this is a 1. That means 12 times 13 equals 156. 156. So what strategies did we use for this? Number one, we used our concrete model using the base 10 blocks. Number two, we used our number bond to decompose the numbers into tens and ones. Then we used the area model and we got the partial products. And that's it. That's how we multiply numbers using area models and following the concrete representational abstract sequence. Today we didn't use the abstract, but that's coming up in future lessons, okay? Thank you very much for joining this channel. Thank you very much for watching these videos. And remember that we are doing this for you, for the kids of Dix Latham Elementary, for the kids anywhere that need this type of video as a refresher of how to multiply. I hope my accent is not getting in the way too badly. And guys, leave your comments, leave your questions, leave your ideas down there in the comments. And I will see you in the next video, okay? Take care and be good. Bye.